I'm Chris. I work with the RCRB program, and this is the Coriolix breakout session. So that's not what you wanted to do with your after lunch. Figure that out. uh, okay, so moving right along at the top of my lungs, what are we going to do today? I am going to be honest. I have never led a breakout session before. I did some Googling. I'm supposed to get you guys involved. So I have a PowerPoint because they were due on Wednesday and they were like serious. But we don't need to follow it, right? So if anybody wants to interject, ask a question, that's totally fine. But I did lay out kind of a start where, what I want you to do is to better understand what Coriolix is. You probably heard it a lot of times today and may not have heard about it before. I want to provide you with some information about what the Coriolix specialized service is for the academic research fleet and let you know how you could get started if you are interested. The approach is, so we're going to do like a little introduction of the software, take some time to demonstrate the features. Oh, this is echoing. Thanks for bearing with me while I figure this out. And then talk about some like common use cases, or maybe I have a kind of a canned demonstration of a troubleshooting event, like something that people ask all the time. And then, yeah, again, finish off letting you know how to get involved. Okay. So what is it? Probably should have had a question mark after the title. It's not, this is actually a little difficult to explain. Coriolix, the system integrates functionality across a couple domains that I would think may have been siloed in the past. Those domains being data acquisition, data processing, storage and management, and data access, right? We all do those things in some way for our clients and for ourselves. Coriolix tries to throw a rope around as much of that as it can for the purpose of kind of what Katie was talking about earlier this morning, doing things more standardized and in a more integrated fashion to hopefully, realize some efficiency for you guys, some extra usability for your clients, your science customers. I don't know why I'm talking about clients and customers. I have no background in that. It just came in my head. But it kind of seemed to fit, right? So that's what we're going to dig into a little bits and pieces of that, but that's what we're trying to do. We're trying to orchestrate data collection. So, informing your data acquisition system of how the state we want it to be in, watching that, changing that, data processing. Now we're looking, with Coriolix, we are kind of stretching, or maybe blurring that line a little bit, but we allow ourselves the freedom to look at the data as it's coming in and do things like quality control, like Cortod or something like that, right? You can do that on the fly, transform your data from engineering units to scientific units with like the metadata that we maintain in the system about your calibration and stuff like that. Data and storage and management is still kind of a working area for us. We're working with R2R on like how to streamline delivery of data to them and also facilitate some of their observational or kind of like tracking needs using an API that we have. And really the last bit was we're focusing on how our users interact with the data and kind of barriers to that. So we wanted to offer additional modes of data access, not just here's where you go to find the data, unindexed and good luck. So we're trying to build some services around that. Okay, what does it look like from the driver's seat? When you visit the website, right? So the first thing to know is it's a web interface running on your ship. So you don't have to run up a deck or two to interact with it. You can just pull it up on your ship's network. But the thing to remember is we also have a shoreside presence. It looks the same. Whether you're on ship or shore, you just have a different readout up top that, it's telling me shoreside. I'm on the shoreside site because I was looking at it the other day from my office. Information is synchronized. So the state of the system is, would say, eventually consistent. Within a couple seconds, you get changes that you've made on shoreside are reflected on your shipboard. but there's no dependency. If you go offline, there's no dependency on shoreside. That synchronization is there to allow your colleagues to help you out, right? Maybe set something up for you, change some metadata while you're on deck, and then that information gets reflected back to the ship. So no dependency there. You can be offline for months, but we do that sync. So same user interface. If you dig down across the menu of screens, and we'll have a chance to do that, there's, resources for different use cases, right? You can create an identity. You should. If you're a manager, you're responsible, you're in the tech services, you have elevated permissions. So we group up users into different permission groups, right? So we've got technicians, admins like myself at a higher level, and then science users, and then public. We don't do a lot of, currently we're not doing a lot of access control for the scientific data based on who you are. Right now it's everybody can view and interact with scientific data, but you have to be a technician or an administrator to make any type of change to the system. What's it look like under the hood? The two boxes are ship and shore. It looks like the closer one to me is shore. And the boxes inside the boxes are computers, be they virtual or physical, but they're individual, unit systems. So it's a mirror image for the most part. We maintain a database on the ship and on the shore. All metadata that you enter into that database is synchronized. We use tools like OpenRVDAS or SCS to acquire data, and we pass it off to shoreside through a message broker. So not a database synchronization, but it's a one-way. Wow, I've got a.
I know.
The over/under on whether he eats it and takes everything out. Okay, so many people have told me don't stay out of the weeds, but if you have questions about that, how the back end works, I'm happy to talk about it. I would say that we run on, I might cover this in a minute. We run on a Debian stack. We've been testing on Alma Linux, and we're also doing Docker because we realize we don't want to play which version of Linux am I supported on. So we're Dockerizing it. We're just that's a little bit down the road. Okay, who is using this big giant acronym? I didn't tell you what it meant, but we worked really hard to come up with something like Coriolix, right? But it's the cruise observation, real-time interface for live information exchange. But who's using it? We started out on the Oceanus because this project was spawned out of the RCRV program. So that was the first RCRV replaces the Oceanus, or will replace the Oceanus. So we started a relationship with that team. And we also started working with Eric's team on Endeavor, and Eric and Bill and everybody. I'm not going to start names. Point Sur also. And so these were groups that we could work with. It was okay for us to work with. These were our project collaborators and our friends. And that's really important because we're being funded out of major MREFC, which is basically research construction funds. And so it was difficult to collaborate with people in the fleet, right? So we had this kind of problem as our project drug out, and we're late on delivery. I don't think I'm going to get in trouble to say that, but it was the situation where I really needed to get the technology officially supported on some vessels, before our project was over. So the academic research fleet supported a specialized service. This was last year and renewed it for this year. So that's now I'm allowed. I'm allowed to work with groups like the Coriolix. So they went online last year in kind of a test state. We were running two systems, their existing system next to ours, kind of to get comfortable. RV Savannah, I'll be there in about a week and a half. And then the 3 Tawnies are coming out. So that's kind of my world in the academic research fleet. And Katie mentioned this morning that she's got 15 ships and a weather station. So that's 2025 is is going to be very NOAA focused for us. But we proposed and we very much want to build that list on the right, you know, so I'm here to talk to people about how to bring it to your vessel. So please, and what's going on the left is independent, right? I want to make connections while I'm here. So that's where we hope to add one more new ship per year. I think that's undershooting, but we could probably do better. Okay, what do you need to run this junk? It doesn't take a lot. I don't even know the slide makes a lot of sense. It really depends on the size of your vessel, but our smallest deployment on the Point Sur is a one socket Dell 430 or 440 or something like that. So one CPU, not too slow, and a bit of RAM. Somewhere it's going to cost you somewhere around $3,000 to $5,000 to invest in like a piece of hardware like that, depending on who you get it from and what your relationship with them is. I don't have funds to do the ship side hardware, but I can support shoreside installations from infrastructure that I have at OSU. So we can, that's kind of the barrier to entry, or that's what it would take to physically deploy. So I've already started talking about this specialized service. So I should just want to tell you a little bit more about who we are. There's three of us officially that are drawing salary on this project. Myself, Jasmine Horniak, if you were here last year, she gave a talk about Coriolix, and then we hired a full-time developer whose name is Tristan King. And so I'll have a slide of everybody's pictures. There's actually 4 people. I am so sorry, James, you're on the line. James Kaysen is also part of this project, and I owe him a beer. Okay, so before I leave this, we already talked about the pilot project, and now we're in a cycle of kind of 1-year funding to see if we can, stay alive in the fleet. You should know that we can do this remotely for the most part. I'm going out to the Savannah next week because I can. I budgeted for it this year, and it's a smart thing to do. But I don't, if you're worried about, oh, how am I going to do this at a port call? We've been doing a lot of upgrades lately and kind of working out our bugs and how we work with different boats, right? So I think 3 days, something like that, to start from scratch is reasonable to go to a new ship. Why is NSF interested? I already covered this. The RCRV was a big boat, right? It grew and grew and grew, but it's not a global. It can only take a certain number of people. And NSF recognized that they want to do, like telepresence showed us that we could work remotely and operate, exploration, but we weren't fully utilizing like a quantitative data to information back and forth, right? So I believe that their vision was like, let's build that. So that's I think that's why we're here. And we want to leverage, the other thing we're trying to do is leverage other programs that are out there, right? So trying to support R2R and Samos, or supporting them a little bit better than maybe we had before. We want to take advantage of products that NOAA's producing and bring them to the ship, or something like Vicky's producing with the GMRT, and make those resources available on the vessel. So that's another kind of component of Coriolix. Okay, the people. Myself, Jasmine, James, and Tristan. Thank you. I got a little out of order. Yeah, Jasmine and I have been here doing this since 2015. James has been on in 2022, and I just got Tristan. So each person has kind of a little different role. Jasmine does the lion's share of the development. Tristan's going to now help take over with that. And James provides like our sensor to network guy, right? Like he really knows how to set all that stuff up and kind of does design review and all kinds of stuff for us. So inside of the service for Coriolix, like what did I tell NSF I was going to do for them and for you? The first kind of service component for me was to make a commitment to maintain the code base for Coriolix, right? So what does that mean? The first kind of bullet was security compliance, or not creating a security problem is really important. So we committed to watching for vulnerabilities and patching them. I don't have inside the team, we haven't yet kind of like shook a hand on like what is our SL, like when or how long are we going to give us? I heard some interesting units of time yesterday in somebody's presentation that kind of helped me scale, where should I start? But that's something that's really important for us. And then so after, if we're managing that or monitoring that, we want to incorporate those changes that need to be made, so if like a patch release comes out, get it into the code, get it tested, and then update our boats, if it's a certain level of severity, right? So, and then just to commit to listening to your needs and implementing what you guys want to see in the software. So that's kind of my service, code-based maintenance service that I wanted to commit to. But one topic on that, and this has been recently a little bit more of a problem, we always intended to release as an open source software, and we still do, but our project execution plan ties us, well, when I say ties us, it doesn't mean like it's a bad thing. We identified the delivery date of the first boat as like a responsible time. Like we are going into production to operate RCRV. We have a trials year. This is a product that was developed for RCRV. I have these responsibilities. So that was I think it's still a smart release date to start having people kind of start contributing to the project. So that's where we're at. It has caused a little bit of trouble, if somebody's trying to write a proposal and wants to be able to put down like, hey, I'm going to do this, and how do I officially, is it open source yet? So that's the kind of pressure or friction that I've seen around that. I haven't, the funding agencies, either NOAA or Academic Research Fleet, are all kind of aware of that timeline. Another service, so that first commitment was to keeping the code base as up to date and robust as we can. And then the second commitment is to work with your vessel and to keep your particular installation happy, right? So we just completed all of our boats except for Endeavor, and we're going to do that next week. Got a basically upgraded version, so we finally got everybody's on the same level. And in a week or two after doing Savannah and Endeavor, all boats will be at the same exact version, and then we can kind of plan when the upgrades are going to happen for every boat. That was like our starting point this year. So that's performing the regularly scheduled updates and patches for you, and then also to work with you. This is kind of probably the operator dependent, but how much, what do you feel comfortable with? Like what level do you want us to maintain your system for you? Do you want us to do backups? Do you want us to like patch the OS? Clean your disk out? Like we can work that kind of relationship out some people might want that, some people don't. We typically do that kind of stuff for all of our deployments now because we've been invited onto different boats to test or to trial, and that with that kind of comes the responsibility. It's not part of their kit yet, right? So we do a little extra on those. Client support, on call. Talk to Ethan or talk to Carmen or somebody on Endeavor like Bonnie to tell. We tried our best to respond to emails about problems if it's on the weekend. We don't have a formal, we're going to be there, this many days a week, but we understand, and we can change that if that's something that needs to be more forward in Coriolix. That's fine. We do set up and training, and we're just starting to get to do science support. I think last week was, I got an email from somebody that was on the Coriolix. I heard that I could get data here. How do I do it? So I've been waiting for that, right? Like that, it feels really awesome when somebody calls you to ask you that. I'm going to end probably really soon, and then we can do a demo. And let's look at the time. I don't have a good sense of time. All right, we got time. I just wanted to mention that other users have started building on top of Coriolix. Ian Black is a graduate student. He's got a GitHub project where he's kind of written a Python wrapper around our API to allow him to, you know, quickly generate plots and stuff. I believe it is public and I can get you a link to it. I apologize, I didn't have it in time to put in the presentation, but we will get that. And then UAF, I noticed we were on the ship not too long ago, and Julian's like, hey, I'd like to get some, you know, kind of status dashboard, some of his own, you know, unique needs. And I know he's had some experience building Grafana dashboards on top of it. We did contribute a breaking change to Julian's Grafana setup in our last upgrade, but we're going to work with him to. A lot of the changes, like the frequency of big changes, is starting to settle out, right? You know, changes that change field names and data tables and stuff. I think we're through that, and that feels good also because that's a really painful time in the development phase. Okay. I have a canned troubleshooting example. We could start now, or I could take a step back and just maybe tour you through, like maybe save the demo or the troubleshooting for after you've seen a little bit more of the interface. Does that sound good?
Yeah.
Okay. Thank you. I just was looking for somebody to nod. All right. I'm going to try to get to a browser. It's always harder when you're in front of people. There we go. Which tab was it?
That's a respectable Google search right there.
That one. Yeah, thank you. My bad. Oh, I'm gonna actually do that one. Yeah. Yeah, you're good. Yeah, having a little bit of the desktop there might actually help. Okay, so I promised that we would do a live tour. We are viewing the shoreside interface for the Sakuliak. I believe the Sakuliak is alongside. Let's double check to see if this works. So, yeah, it's in Newport, so we won't have any nice ship tracks to show. Yeah, so there we are. So some systems are going to be off on Sakuliak. So you arrive on the homepage. One thing I did not do was log in. I'm on somebody else's computer. So I'm going to quickly take you suffer through my password database. Oh, this is embarrassing. So I really love password databases. Not sure. I do want to go back to that screen if that's what you're asking. Oh my gosh. Talk amongst yourselves.
You're gonna take an opportunity.
All right, we're not going to log into this one.
You help for me to log
I was having trouble. Yeah, do you mind? Well, no, are you on the Sakuliak?
Oh, no, I'm not.
I think I still am.
I use Gabe's login, sorry.
You're going to have one of these moments in a live demonstration.
It's just not in.
We don't need this right now.
Switch to the Endeavor, they're underway.
Switch to the Endeavor. I've got Endeavor right here. Thank you for your patience. Okay, here we are. We're the Endeavors. Bonnie. We're gonna go in as Bonnie Clark. Thank you.
I hope I can remember it.
Let me work on my password.
Is it, it's my email, right? Yeah, yeah, that's great. I feel like
I got it.
What's up?
Other line. Practice your. Was it my thesis advisor ringing in my ear?
Well, this.
Yeah. Is it hot in here? It is up here. All right. Allow accessory to connect. Continue. Wants me to hit the one.
It'll work even without it.
I like to spin it through.
He
All
has to
right,
share his computer.
we're in.
He has to share his
That's
screen.
me.
Doesn't have to.
Back to the
Jesus Christ.
future.
Oh.
All right, so we're looking at the sensor status of the Coriolix. Let me make sure I'm on the right
Yeah,
ship.
but they can't.
Nope.
People in my kids are there.
We're looking. Challenge of. Whoa. Perfect timing. It's a challenge. It's a challenge for the system. Step away from the microphone. All right, we killed time. Back to the. Thank you so much. I don't know how you do it. Like, it's a very good job. All right, so we're in our alert system here. If we wanted to create a new value alert, this, you know, you can create a message that you want to send yourself. You can give it a severity level. This is an arbitrary. You can control what means what in your severity world. And then, you know, a condition to alert on by parameter and a value greater than, equal to, less than, you know, so an on and an off condition, right? Go ahead.
I saw that it had an alert for a sensor needing to be cleaned. Is that value based or time-based alert?
Could be either.
Could be.
Yeah. Yeah, you can set that up, right? But we do, okay. That's an awesome question. In the metadata for the instrument, let's see how robust our Tawny metadata is. Sensor status, sorry, sensor list. So, what is, give me an example of something that needs to be clean.
Radio.
Oh, it begins with an R, so it's the bottom.
Fire it on.
You have strainers in it too.
Okay. And we have an auto filtration system, right? So, data collection specs. Oh, I forgot Jasmine has breadcrumb nav here. Maintenance and support, sensor log, calibration and maintenance. All right. You can create maintenance A, B, C. These are just types of maintenance. Make them what you need them to be. We've got 3 different groups at this point. We can make more or less. So here somebody has set up a maintenance event for September 12th, 2023, and that would generate a message to, off the top of my head, I don't remember, but I believe just anybody that's a technician, that condition is, you know, you're past it, or you're, I think you actually can, it warns you ahead of time. I wish Jasmine was on the line. She could tell you all about how that particular alert is implemented. But yeah, you know, we really like, our focus was really like, we want to operate our vessels as continuous observation platforms, even though that's not their primary mission. But if we have resident instruments, we want to be very standardized about how we collect stuff so that it's usable later on, right? So we were thinking about like, how are we gonna track and manage maintenance of, and this, so actually, this was something Katie really had a lot of input on early in the development of the system. Yeah, great question. Another,
Kind of following on to this, actually. So sensor status, is that defined when you look at that homepage?
Yeah.
and Then go to sensor status, is that defined per user, per vessel?
that's a global type of
It's
a
a
thing.
global thing. So we can define parameters on a vessel basis, and no matter what technician logs in, it'll
Yes.
be read per that parameter.
Yes.
Okay, great.
I believe the only one that we have currently implemented here on either, the ones we typically implement to like make people aware of it is you're at your home port. So we have a proximity alert set for your home port so that it shows up, or any port, you can set it up. So I think the Seculiac may have said at port or within 4 kilometers of Newport, that's what it said. So, and then the other one we do is one of your sensors is not responding, it's gone, it's data stale.
And just follow on that real quick, is there a way to, if we have duplicate sensors, if there's a difference between one sensor and the other, they should be the same, is there a way to create an alert for that?
Yes, on the previous screen, there were 2 conditions, like you could do a second condition for when the alert was hit, so I believe that's what you
Okay,
would do.
yeah,
Yes.
that's good.
And, okay, so you're from the Endeavor,
Yes, that's correct.
sweet. Lynn has been, one of the things we did for Endeavor, I don't have it, let's see if I can pull this off. The Endeavor's out, right? So that's, here's Endeavor. Here's plots combination. So on the Endeavor, they have a number of things that they like to see together as diagnostic. Oh, this isn't as,
Flow through is a good example.
yeah.
Well, we kind of, once we have, if you go to sensor plots, we configured our flow through, because that is user configurable, to overlay the necessary sensors so that we can very quickly tell if one of our sensors has a difference.
Like,
So like, yeah, if you look, that's like, oh, look, the T cell sucked up air.
Yeah.
Like, it's very easy for us to.
Yeah, what I wanted to, so Lynn had this long history of, like, she had this vision of what she wanted to see plotted with what that was diagnostic that she could act on. So she came to Jasmine and was like, I love this, but I got to scroll here to look at this. And so she's like, I want this to be configurable so I can choose what goes with what. And so that's how that happened.
Yep.
Julian.
Yeah, I just wanted to mention, because I'm sure folks are curious, at least on Seculiac, our data transfer volume for Coriolix is roughly a gig a day, give or take.
I'm glad you mentioned that because I haven't updated. So on Endeavor several years ago, did this back of the envelope, like how many bytes in this message, how much bandwidth am I using? And then did a quick Wireshark or something to validate that. But we're talking about between Endeavor and Seculiac, I don't know, 4 times as many, a lot more than that, probably 5 or 6 times as many data loggers running at one time. So when we were talking about processing impact, I start really needing all that RAM for a ship like Seculiac, where maybe every one of those data loggers is doing some type of transformation. That's where the pressure is. That, and we create. So each data product, right? Each sensor with parameters the parameter gets logged in a table, just a time series, right? But we don't do our navigation on the same sampling rate, so we have that problem of like there's no nav with it. So what we do is we create 2 products. The first product is a default binned data product where we bin on the 1-minute interval all the parameters, and we compute the bins for every data point in 1 minute, the best data points. So we're looking at our flagging. So we use, we do on the fly flagging. So if if we're flagging bad data, our second bin, or our second data product in that bin set is gonna be just the best values. And then we do a binning that is specified by Sean and the Samos team. So we create 3 averages, or for that bin, and then we give you all of the mean, median, standard deviation, and all for each one of those. So it's a complicated data object. It's like a little JSON blob in each cell, which makes it more complicated to display. But that's something that we really like. We can transform that on the fly and publish that as a data service that just has the value for you, right? You tell us if you want the best, the all, the spot value, whatever. What I'm trying to say is that's like a product that we think is super useful. That's what we always heard when we were visiting boats. Like, don't forget that most of the science team needs something like that they can just really quickly grab, and they don't have to, interpolate to use. And then we create a second product, but it's exactly the same, but we allow a user-defined time interval. So I don't know, somebody shows up on your boat and wants to do it every 10 seconds because whatever they're interested happens on that frequency. So you got that flexibility. Go ahead, John.
Just some math following on Julian's comment. That's about 100 kilobits a second average number. If you're moving about a gig a day, so just in terms of planning for your link budgeting sort of thing. By comparison, some of the IT stuff that we monitor and ship over the air, I can tell you the exact quantity of things, but we're moving about 300 kilobits a second, so 3 times the amount of data just to monitor state of health on IT infrastructure.
Right.
So it's not a huge number
No, it's not. It's
these days.
like Katie was saying earlier, yeah, I'm glad you chimed in on that, because it's like, I don't know how that scales, unless you're the only person that knows how, like this is the day. Katie was talking about that big data problem. Like when we were starting this, we knew that we could not physically move multi-beam data or EK80 data to the beach to have somebody process it and then return us a bathymetry grid. That would be awesome. Now we're getting into that space, and it's cool to see some of the vendor solutions. I know Kongsberg has an edge.
I mean, we were able to ship multi-beam data back over the old links like 15 years ago, but it would have been to the exclusion of everything else.
Right. Yeah.
Now the throughput, we multiply that a couple orders of magnitude at least, capability wise. And so this kind of data is thankfully in the noise of what's sustainable. Broadly speaking, the thing you have to be careful about is like an unintentional force multiplier where someone's like, 1 hertz, I want 10 hertz, and all this, if you do that everywhere, that could be a different story, right? But,
Yeah. And to dig a little bit, like there was one slide that said, we've got a message broker that gets the data to shore. What the heck is that? Under the hood, for every instrument that you have an open RVDAS data logger. I think I can. No, this is not my laptop. We create a publication as an MQTT publication, right? So there's a broker on shore, and we publish. So if you're the Coriolix and you have a TSG, and I'm going to make this up, but it's like TSG 0000005, right? We create a publication, Coriolix TSG 005, and that same message that's coming in, it has time, instrument name, and then like the payload. We just send that to the beach, and we set a priority, the lowest quality of service level we can. And what that means is it's going to just send it one time, and it doesn't care. Like there's no checking to make sure it's at home. So what happens on the shore side is you could get holes in your data. You do, whenever you have a network outage, but that way we're not trying to retransmit. We can, I believe that it's like a user decision on a cruise by cruise basis. It's your decision, not mine, but you can increase the quality of service on that ship to shore data transfer to say, okay, it's going to take you more bandwidth, but like make sure this message arrives at home. So it'll queue up some stuff in a cache and then push it when it can. That could go wrong if you're out for too long. We all know what happens on satellite networks. You can do it a third level, third quality of services, send it home and make sure they get it, and make sure they get it only one time. So it's even chattier. But there are switches under the hood. We haven't experimented a lot with that because we're really just now getting to the point where we're gonna have shoreside users, that's kind of like I was telling you, like it's just happening right now. Like people are calling up, and so those are things that we're gonna deal with and learn this year. How does these quality of service settings change that 1 GB number? Probably, I'm gonna guess, could triple it.
Yeah, I mean, it would not be surprising to have it turn into something that's comparable.
Yeah.
Or bigger than the IT state of health.
Don't be shy telling anybody that. The data making it home, you can get all your underway systems for home for like roughly the same overhead as your engineering data, right?
And I know you're out of time, but just really quickly on Sekuliak anyway, what we're doing is utilizing the idle C-Link bandwidth to send this data ashore. So happy to show folks how we can do that with the new FortiGate if anybody's interested.
Thank you for coming. I'm here till Friday. I apologize with my password. I'm sure my office mates it's gonna be something on the whiteboard when I get back.
Should I, real quick, I wanted to say that, I think this system has so much potential and we didn't have enough time today to even get into all that much. So I think maybe if we want to do another demo at some point, we could probably set something like that up
Sure.
with the group.
Yeah.
Online, like a Zoom meeting.
Exactly,
I think
that would
what's
be
neat-
cool.
Yeah, I think what's neat about this is that, we've got smaller ships like the Point Sur, who don't have a lot of IT capability, who are using this and happy to be using it, and it's being very helpful. And then it's also got the larger ships, and it's also great with the metadata. I don't know how much you talked about that, but just keeping track of all that metadata that we all have to keep track of now. So if there's any interest in that, go ahead, Brandy.
Have we used the training committee Wednesday, monthly, quarterly meeting?
We haven't.
Coriolix?
That's a good idea.
We could do what was wrong Wednesday, Coriolix.
Perfect. Put it on the list, Chris. That sounds great. Okay.
I didn't get to this
Get it out.
part, but explore the data access. There's an ERDAP server under the hood. There's an API that does JSON. ERDAP will serve you data and transform it across like ASCII, NetCDF, OpenDAP. There's a lot of power under the hood for API kind of stuff, but you don't see it. So explore.
Great.
Thank you.
All right, you can keep talking.